Hello, 7th graders. Let's go ahead and begin on the lesson 3 practice problems. For number 1, it says it takes an ant farm 3 days to consume half of an apple. At this rate, in how many days will the ant farm consume 3 apples? All right, so I kind of preset my table here because during the lesson I kind of taught it this way. We just kind of made some tables and we were looking for the constant proportionality, but we're also calling it unit rate at this point. Maybe you remember that, but that's what I'm going to do. So it takes the ant farm 3 days to consume half an apple. So half of an apple, 3 days, right there. And that information alone is going to be enough to tell us the unit rate. So we're going to look for, the unit rate is the same as the constant proportionality, which is the y divided by the x. And in this case, it's 3 divided by 1/2. 3 divided by 1/2. All right, so I'm going to do 3, and then I'm going to flip the second fraction, keep the first fraction the way it is, change division into multiplication, and then you get 6/1, which equals 6. So there's your unit rate, which basically says that, what does it say? It says that k equals 6. In other words, you take the number of apples, and if you multiply that by 6, you're going to get the number of days. Okay? So that is what we're going to do. Okay, so the question here is saying, in how many days will the ant farm consume 3 apples? All right, so I'm going to put the number 3 right there, and this is going to be a simple process here, just multiplying by 6. Multiplying by 6 there, and so that is 3 times 6 is going to be 18. So I'll take 18 days. For number 2, to make a shade of paint called Jasper Green, mix 4 quarts of green and 2/3 cups of black. How much green paint should be mixed with 4 cups of black to make Jasper Green? All right, so just like we did in the last problem, let's set up our table of information here. So 4 quarts of green. So you got 4 quarts of green, and you're going to mix that with 2/3 cups of black. So obviously the green-black ratio, there's a much higher green ratio, or much higher green content, than the black, telling us, that this is going to be more of a shade of green than it is a shade of black. All right, so what we're going to do here is just do the same thing. I'm going to do 2/3 divided by 4. That's our y divided by our x. And I'm going to flip the second fraction and change division into multiplication. And then that becomes 2/12, which reduces to 1/6. So there's your constant of proportionality. So you're going to multiply by 1/6 there. All right. If we're going that way. If we're going the other way, we're going to divide by 1/6, which I think is what's going to happen. And that is right, because the question is asking us, how much green do we need for 4 cups of black? How much green do we need for 4 cups of black? So this time around, we're going to do 4 divided by 1/6. We're not going to multiply by 1/6 because we're going the other direction. And I'm going to keep the first fraction the way it is, change division into multiplication, and flip 1/6 to make it basically just 6. And in essence, this is just 4 times 6 now. 4 times 6 is, I think, 2,000. No, it's not. It is 24. So 24 quarts of green are going to be mixed with 4 quarts of black. Okay, so number 3, an airplane is flying from New York to LA. The distance it travels in miles, d, is related to the time in seconds, t, by that equation. So this is where you guys got to get used to using that equation and understanding what kind of everything means. Now this is in that y, it's in that y equals kx form. Of course, we're not using y, we're not using x, we're using d for distance and t for time, for this number of seconds. All right. And so how fast it's flying is right there. It's under your nose. It's right there. The speed at which it's flying is 0.15. Now your job is just to be able to interpret that. What does that mean? 0.15, what, miles per hour? Miles per minute? Well, this problem was saying that d is distance in miles and t is the number of seconds. So that's going to be 0.15 miles per second for every 1 second. So that's a unit rate at which that airplane is flying. Okay, which makes sense because airplanes obviously travel pretty fast. All right, and so how far will it travel in 30 seconds? Well, now it's just a matter of just multiplying that. So we're just going to do 0.15, and you're going to multiply that by 30. So 0.15 times 30 is going to be what? That's going to be, well, 3 times 15 is 45. So that's going to be 4.5 miles right there. For question C, it's asking now how long will it take? So it's asking for the time. And we're not going to do that the same way we just did the other one. I'm going to set this up more into like the equation format. So we got 0.15 t, which is the speed of the plane, times the number of seconds is equal to distance. Now for this problem, we know the distance is 12 3/4 miles, so 12.75. And what we're going to do here is we're going to divide. We're going to divide by the unit rate or the constant proportionality. We're going to divide by 1500ths. So 15.75 divided by 1500ths. Okay, so I'm going to use my fun calculator here, which is not always the most trustworthy thing. So I'm going to do 12.75 divided by 0.15. Ooh, I don't know if it's going to identify that. Oh, there it goes. So there it is. So 85. So what is that, 85 hours or something? No, it's 85 seconds. 85 seconds. Which I think that's asking us, I don't think it necessarily says that we have to do it this way, but I mean, I want to regroup that a little bit. That's, that's over a minute, so we might as well regroup 60 seconds into 1 minute. Okay, and then we have 25 seconds on top of that. 60 plus 25 is 85. So 1 minute, 25 seconds. All right, so there's that. Done with that one. All right, for number 4, we'll leave this open. All right, for number 4, a grocer can buy strawberries for $1.38 a pound. So write an equation where C is the cost and P is pounds of strawberries. Okay, so this equation is going to look very much like the other one. Now, I know a lot of you sometimes struggle with this, but it doesn't hurt to just kind of write it both ways. If you just don't know where you're going with it, just write it both ways and just see which one makes more sense. So if I do like C equals 1.38P, or maybe it's P equals 1.38C. So, and we know from the problem that it's $1.38 per pound. It's $1.38 per pound. So if we put in the number 1 for pounds, we should get an output. We should get a result of $1.38. Now the only one where that makes sense, is right here. So if we put in $1.38 there and multiply by 1, you're going to get a cost of, well, identity property tells us it's going to be $1.38. Because anything times 1 is itself. Okay? So if you're ever trying to figure out which equation you use, just maybe write out both and plug in a number and see which one makes more sense to you. That's not a bad idea. Okay? Pardon me. All right, so a strawberry order costs $241.50. That's mighty big strawberry order. It's probably like from a restaurant or something. So how many pounds did the grocer order? Okay, so I'm going to set this up into the equation we just got. So I'm going to do 1.38 P equals the cost, $241.50. All right, and so I'm just going to divide both sides by $1.38. $1.38. I know we really haven't formally had like an equation lesson yet, but we're going to get there pretty soon. But hopefully you're getting a good idea of how to solve real basic one-step equations. So 240. Whoop, that didn't come out right. Let me try that again. So I'm not doing that right. So $241.50 divided by $1.38 is 175. So yeah, that makes sense. I wouldn't say that makes sense for my household. I would say that makes more sense for like a restaurant or perhaps ice cream store, or maybe it's I don't know, just somewhere they make desserts, maybe just a fruit market. Who knows? I don't know. But 175 pounds of strawberries. All right. Number 5, Crater Lake in Oregon is, I probably said that wrong if you're from Oregon. If Crater Lake in Oregon is shaped like a circle with a diameter of about 5.5 miles. How far is it around the perimeter of Crater Lake? So 5.5 miles. So the picture I kind of cut and pasted in there is kind of a map picture there of Crater Lake. Obviously, it's not a perfect circle. So this is going to be for estimation purposes, but it's probably going to be pretty close, I would assume. So the diameter, the distance across it, through the middle, is 5.5 miles. So 5.5 miles across it. Okay. So how far around the perimeter? How far is it around the perimeter? So that doesn't say so, but that's basically saying what's the circumference, right? What is the circumference of Crater Lake? We're looking for the distance around it. Okay, you're on a hike, maybe, and you want to know how long would it be to walk around that lake. It's probably not just a casual stroll. It's probably going to take you a little while, but not forever, of course. But so you need to figure that out. So we're going to do, for this one, we're going to do circumference formula, which is going to be circumference equals pi times diameter. And we're going to do for this one 3.14 times 5.5. 5.5. So I'm going to do 3.14 times 5.5. All right, and that's almost 8 miles, so 7.85. No, that doesn't make sense. That doesn't make sense. Let me try that again. This calculator's sometimes bad. I just realized that does not make sense. I'm glad we kind of have this opportunity to talk about that, because I know that the circumference should be over 3 times the diameter. So it should be over 15 miles, okay? Probably, maybe closer to 20. Let's see here. Let me try this again. 3.14 times 5.5. I'm going to do it like that. All right, so 17.27. Yeah, that's a pretty long walk. Those people walk around, what, 3 miles per hour on average? So if that was 18 miles, it would be a 6-hour walk. So probably pretty close to that, given that it's not a perfect circle. And now it's saying, what's the area of the surface of Crater Lake? Now, in order to figure out area, we need to know what the radius is. And the radius is going to be half of 5.5. It's going to be half of 5.5. So 5.5 divided by 2 is going to be 2.75. 2.75. All right, so area is, let's do this. Area is pi times radius squared. So I'm going to do 3.14 times 2.75 squared. All right, oops. So that's 23.74. So it's about, and I'm going to round this, it's about 23.7 square miles. That is the area of that lake. There's not almost 24 miles that, I'm probably going to do this very good justice, but you know, a mile, if you have a square that's 1 mile by 1 mile, we can lay almost 24 of those miles, those square miles on top of that, if that makes any sense to you. And then for number 6, a 50 centimeter piece of wire is bent into a circle. What is the area of the circle? And I couldn't find any really good images of wire bent into a circle, so I kind of found this is artsy fartsy little picture. Hopefully not taking this from someone's like personal picture stash. I think it was from Google Images. But yeah, it's a 50 centimeter piece of wire. Okay, now this is obviously, you know, it's not exactly a circle in the picture, but imagine it is. And that, you know, this 50 centimeter piece of wire is basically describing the perimeter of it, which is the circumference. Okay, and so this is one of those really fun questions where when you have circumference, you can pretty much figure out anything. You know, you can, once you have circumference, you can figure out diameter. And if you know what the diameter is, you can figure out the radius. And if you know what the radius is, that will tell you the area. So it kind of goes back and forth. You know, if you have area, you can pretty much, if you kind of do the square root of both sides, which I don't think it wants you to do yet, but you can, you know, given one of the two, if you have area and you have, or if you have circumference, that's pretty much enough information to tell you everything you need to know about the dimensions of that circle. And remember, circles don't have a length and a width, they have a diameter. That's pretty much, I guess you can call that a width, but it's the segment across the center of it. All right, so this, like I said, this is describing circumference. And circumference is pi times diameter, right? Pi times diameter right there. So we're going to do 3.14 times d. Here, I'm going to set it up more like an equation. Do it like this. 3.14 d equals 50. Okay? So that's what I'm going to do right there. And then we're going to divide both sides by pi, by 3.14, to figure out what the diameter is. All right, so that is going to be, I'm going to do 50 divided by 3.14, and that comes out to about 15.9. So I'm going to write that out. Is 15.9. So the diameter is, I shouldn't say equal, I should say it's approximately, right? 15.9. It's like 15.923. Okay, and then if we want to figure out the radius, we're just going to divide that by 2. Let's see if this works. Oh yeah, it does. So 7.96, which is, you know, maybe I should have used 2 decimal places. But the radius, if I round that, maybe I'll just keep it 7.96. How about that? Not to confuse everybody. 7.96. All right, and that's going to be the number we're going to use to find area. We're going to do for area of a circle is pi times radius squared. So we're going to do 3.14 times 7.96 squared. So 3.14 times 7.96 squared. And there we go. We got 198.955. All right. And so I'm just going to round that to 2 decimal places. And I get 198.96. And this is centimeters. So I'm going to do centimeters squared because area is always square units. Square centimeters, square miles, square inches, square everything. All right, now this next question is a throwback question, which is asking us to kind of just basically figure out whether they're scaled copies of one another. And all it says about quadrilateral A and B is that they're squares. Now, the thing is that squares, very much like circles are, squares are always going to be proportional. Always. It does not matter if one is smaller than the other one or the other one's bigger than the other one. A square is always going to have a scale factor because it doesn't matter. Like, let's say this is, I'm going to pick like a kind of a terrible number here, but let's say this is like 9/5, okay, which is 1 4/5. All right, and let's say this one right here is, I don't know, how about 3/4, or how about, I don't know, I want to use a good number here. How about 5/8? I don't know if that's the greatest to use, but yeah, those numbers don't look very similar, however, but you can still figure out the scale factor. All I have to do is 5/8 divided by 9/5. I can figure out what the scale factor is from the blue to the green square. So I just do this and 5/9, and I get 25/72. Kind of an ugly ratio there, but if I want to figure out the sides, every side of that square is going to be 9/5, right? And so 9/5 times 25/72 is always going to result in 5/8, no matter what. It does not matter what numbers we have there. Squares will always be scaled copies. Well, I should say, regular shapes will always be scaled copies. This is not a great regular hexagon or a pentagon, but regular hexagons, octagons that look like a stop sign, they're going to be scale as long as they're regular, where all the sides are the same length and all the angles are equal.